9:02. Hi, everybody, and welcome to our Data Science Education webinar. This is our first of 2018, and we're kicking off with Bill Finzer, who I'll introduce in a minute. This webinar is being made available through the Concord Consortium, which is a nonprofit ed tech laboratory based in Concord, Massachusetts, and we're here in Emeryville, California. You can learn more at our website, concord.org/meetup. I'd like to introduce you to today's facilitator, William Finzer of the Concord Consortium. William goes by Bill. His work is long centered on getting students using data in every subject that they study. He led the Fathom dynamic data software development team at KCP Technologies before joining the Concord Consortium in 2014, where he leads CODAP and the Data Science Games projects. And in this webinar, we're going to take a look at CODAP's strengths and weaknesses with respect to data science education. A recorded version of this webinar will be made available on YouTube. We will email you details about it through the Eventbrite page after the event. And if you're comfortable sharing your name and face, please turn on your web camera during the webinar event. We like to see and hear you. I'd also like to emphasize that the format of this webinar is participatory by design. This means that we will work together to decide the conversations, connections, and activities that we want to discuss today. Bill and I will be facilitating the live questions that you have, and I will be the text-based questions on Zoom chat or Google Docs. Bill will explain what that means in just a few seconds. For those of you just joining us, welcome to our webinar. Our speaker today is William Finzer, who will be talking about CODAP's strengths and weaknesses with respect to data science education. Bill, I'll let you take it from here.
Great, thank you. And do you want to stop sharing your screen?
Yes.
Okay, so Talia did a good job of introducing me. And since we're going to be talking together, it's helpful if we all know the minimum about each other, aside from our faces. So I can see you all on this screen in front of me, and I'm going to call people to give a very brief introduction of themselves. So Jessie, you're first on my screen.
Okay, I am Jessie. I am located in Dallas, Texas, and I work as a data scientist with an educational leadership organization. But I'm here primarily because one of my side projects is looking at developing data science job training for opportunity youth who are kids 18 to 24 who are out of work and out of school. So I think it came across CODAP in the webinar, so really excited to learn more about it.
Perfect. Sibel, you're next.
Okay, hi. I'm from Turkey. I teach pre-service mathematics teachers. Sorry, excuse me.
Let's see, that's Jenny. Jenny, if you would mute. Thank you. Go ahead, Sibel.
Yes. I don't know the whole group. I might be the newest one to talk about the data science. I think I knew about this project. When I was working with Cliff Connaught at UMass. But now I'm interested in also through a project how to engage students in data analytics to analyze real life data like climate and weather type of data. So that's why I joined this webinar, to learn more about it.
Great. Tom, a brief introduction.
Hi there, my name is Tom Farmer. I live in Maine in the United States. So the other side of San Francisco and Dallas, I suppose, and halfway to Turkey. I'm working on 2 projects with the Concord Consortium focused on inquiry and student experimentation, and data is at the heart of both of those projects. And I'll leave it at that for now. And I used to work with Maggie.
And Maggie's next.
Okay, so I'm Maggie. I work at the Gulf of Maine Research Institute in Portland, Maine. And I'm part of the Vital Signs program, which is a citizen science program. And a huge focus is helping students engage with data through the vehicle of citizen science. So that's why I'm here.
Mary?
Hi, I'm Marian. I'm based in San Francisco Bay Area, and I used to work with Bill at Key Curriculum Press and KCP Technologies a lifetime ago. I'm now currently working with Great Minds, who are the creator of Engage New York and Eureka Math, and I'm just kind of curious what Bill's doing now, because I'm a huge fan of Fathom, and just trying to familiarize myself with what his new projects are and how I might be able to help.
All right, Doug.
Hi, I'm Doug Stein. I'm currently living in Coral Springs, Florida. I moved from the West Coast to Rhode Island and then Rhode Island to Florida. Many years ago, I actually taught statistics and data analysis to high school students when I was a teacher. It was one of the courses I did. I also have experience with Bill and with Key Curriculum. I was consulting for Karen and the team there a couple years back. And I'm currently one of the founders of a company called Metacog, where we use data to observe what the student is doing and use that data to infer how they're performing in open-ended tasks and to evaluate also the content. But what I love about CODAP is it's a chance for the students to be actively engaged with the data and doing something with it. And you know, that's somehow we'll avoid having the snake eat its tail, but we'll get the benefits of all possible uses of data, people, and content interacting with each other.
Great. Joan, you're next.
Hi, I'm Joan Heller of Heller Research Associates in Oakland, California. And we got to be part of the research team on CODAP. And so we're enjoyed being able to see it develop over time and work with the partners and do a lot of cognitive interviews with students as they analyze data using CODAP and explore data. We're now the evaluators for the next project with this data science games with Bill and company.
Thank you. Jenny? You have to unmute yourself.
Yep, good morning. I hope you can hear me okay because I'm not using my phone. My name is Jenny Hicks. I work at iSTEM at Purdue University. We're a STEM advocacy agency for the state of Indiana, and I manage a project called the Indiana Science Initiative, which provides hands-on science curriculum for roughly, we just went through a change, so we're not quite, we're had a textbook adoption, so it's not textbooks, but you know what I'm saying, materials adoption. So we service probably 30 school districts in the state of Indiana, and as a result of that work, we also work on increasing professional development for teachers and retaining them. And so my interest in this is because we have a math science partnership grant, which is ending, and we also have a grant with the state of Indiana to provide STEM mentor teachers for teachers, and we provide professional development for new teachers. And I kind of see this as the next wave, and I want to get this introduced in Indiana, and my compadre is on as well, Jeff Thomas. He's a professor at USI, and he can introduce himself if he hasn't already, but we are working to, I would really like to learn as much as I can about this. I'm a former scientist, and so I'm just really excited about this. And so I want our teachers to learn how to use this, and I'd actually like to bring it down to the down grade levels. I'd like to bring it down to the K-5 arena if we can, because I think, you know, if you're a teacher, doesn't matter, you really should be doing this yourself in professional development, even if you're not doing it with kids. So thank you.
Thank you. Thank you. Dan.
Hi, I'm Dan Damelin. I work with Bill on helping to develop out CODAP at the Concord Consortium. And we use CODAP in many other projects that I'm involved with. And so I have a keen interest in how it goes and how other people interface with it and how it can be used. many of those projects are using CODAP as sort of a graphing library, but in a sense, one of the projects that Tom Farmer, who's also in this group here, is working on is exploring students' understanding of data as it intersects with experimentation. So we'll be, I'm looking forward to Bill's webinar today.
And Jeff, we've eaten into your half hour quite a bit, but.
Oh, no, that's okay. Jenny already mentioned me, but day in and day out, I prepare elementary teachers, and we work together with training teachers across the state, and we want to explore the possibility and the relevancy of the program to elementary teachers in our professional development work with them.
Okay. And Mehmet, can you speak to, oh, there you are. You need to unmute yourself.
Okay, yeah, I need to unmute myself. Yes, I should learn this by now, but all right. Well, I'm a science educator at the University of Tennessee, Knoxville, and I've been thinking about, data science and how we can incorporate, data practice into pre-service and in-service teacher education, and also look at, how the products that you guys have developed can be adopted at the K-12 level in the class that I work with.
Well, great. This is a wonderfully diverse group. And I am going to ask you to make a leap of faith in just a minute, so prepare yourself. I think all of us are aware of the rise of data as a foundation for our society and the emergence of data science as a field that's important to our society in making use of the incredible amount of data we have. And probably most of you are aware that there's a great need for more people in the workforce who understand how to work with data. And that need has been recognized at the college and above level, so that there are many programs, certificate programs, degree programs in data science happening at the college level. At the pre-college level, not much, right? There's the data stuff that's been there for a long time. The chapters in the math book that the math teachers usually skip. And statistics education, Common Core standards in mathematics that bring up data, and standards also, the next generation science standards have a lot in them about data. But those standards came about pretty much before the rise of data science. So we have the question of, well, how is data science and learning data science different than the curriculum that has been advocated for in the past? And we have a very difficult question. If we believe, as I do, that pre-college students should be engaging with data, how do we bring that about? So I don't know the answer to that. It's something that I want to spend time working on. But here's the leap of faith. I want you to move with me into a world in which grades 4 through 14 students, so I've included the lower division college students, are actively engaged with data all the time. And now I'm going to share my screen, and you will shortly join me, I hope. Good. All right, so we're going to be, here, I've got the invitation to make this leap of faith with me. that in the long term, we expect that learners will routinely make use of data in all subject areas. Let's be optimistic and call this learning and doing data science. And of course, to learn and do data science, you need to use software. The question for this webinar is, what should we expect of this software? And we're going to use a particular piece of software, the Common Online Data Analysis Platform, or CODAP, as kind of a sounding board or springboard or straw man to help us think about this. So CODAP is software that's evolving. It's free, it's online, it's designed for use at the school level, and it's being used in many projects currently, and hopefully more as time goes on. But it's not yet the software that I think we should be imagining, but we can use it as a way for all of us to have a common experience and then talk about it. So if you would arrange your computer so that you have the screen share in one window and this Google Slides document, whose URL is visible there at the top, in another window. And because you're going to be working in this Google Slides document. So I'm looking to see you all appear here. When you're here, then I'll explain how this is going to work. I did put some useful links at the bottom, one for the CODAP website, and one for a document that has some guidelines for designing data science education software that I wrote recently as part of a short paper, and I've extracted just the guidelines portion here. And a link to Tim Erickson's blog, Best Case Scenario, and he's got some wonderful posts about data moves as a way of thinking about data science and what should be happening at the school level. Let's see, I've configured this window so that maybe I'm not seeing people, but are people in it? Are you all in?
Yeah, I see fine.
Yes.
Okay, so here's how we're going to do it. I'm throwing kind of a softball out there first. We're going to, it's kind of a given that any software that you use in classrooms had better have easy ways to get kids started, right? So I've called that easy onboarding. And it isn't particular to data science software that you need easy onboarding. It's going to be true of any software, no matter what, that you use in classrooms. And so that we all have a common experience, if you go to this link and choose Open or Browse Examples, and then choose the Getting Started with CODAP, you will find yourself in an onboarding environment there. And I'd like you to just spend a few minutes working through the checkboxes there. And when you finish, come back to this slide. And I'm not sure how this is going to work, but I'd like us all to be writing comments. You can use this box, or you can come down and choose one of these empty boxes. So just comment on the experience. And then when you've done that, think about the question, and this is what we'll talk about. How do we achieve a balance between ease of use or onboarding and functionality. So that's our first topic. And I think if you have problems with that, any problems at all, you can speak up, or you can use the Zoom chat to send a question. But I think we can consider this kind of like a classroom, and we're all doing our thing and talking to each other when we need to.
Could you just repeat how to get to this window, Bill?
This window is this URL up here.
Mm-hmm.
I guess I should copy this and paste it on the next slide too.
It's in the chat as well. If you look at the Zoom chat, there's a link there to click on.
Yeah, I'm at the document, but not.
Page 2, the slide 2.
No, I mean the onboarding and.
So are you seeing this list of slides here?
Yeah.
And the second one is the one I'm looking at. And are you able to get to this link, everybody, and try the onboarding? Yeah, I see some nods. Okay. I wish I could come around and look over your shoulder and see how you're doing. Hadn't anticipated that. Maybe I'll do it while you're doing it. I know how I'll know when you're done because you'll start writing comments. Make a graph. I've got 4 out of 5. By the way, I've never tried this format for a webinar before. So it feels kind of precarious at the moment. Anybody having trouble?
Doug, are you muted?
Oh, Doug, you're muted. We can't hear you. We can see you. If I could lip read, might get it.
Sorry about that. If you type in the same box, you basically, it's colliding edits.
Are people typing in the box?
Yeah.
Yeah, I picked the first one, started typing, and then partway through somebody else started typing, which meant that, you know, extra words were stuck in the middle, even though it was meant to be a separate comment. So getting the insertion point away from something someone else has typed is useful.
Good. That's why I put these extra boxes down.
Yeah,
Yeah.
that's helpful to know.
We didn't, everybody went for the first big one, I think.
Yeah. Why I'm not seeing any is a mystery to me. I'm going to make sure I'm at the same URL you are.
You're also welcome to just type comments in the Zoom window, the chat window, if that's easier for you.
Can do.
Hi, Rob.
There
Good
we
morning.
go. I see them.
Good morning.
Okay. So
good.
Look at those, all those anonymous animals.
It's wonderful to see all these comments coming in.
Okay, so interesting comments on the experience. Yeah, the feedback being limited to the onboarding iframe, that's a good point. Be nice to see arrows and words elsewhere in the document as well. Yeah, this onboarding is focused on actions, but maybe there could be onboarding that focuses on what it's all about. Appreciation of the show me. Does the format of the data file matter? That's a good question. Okay, so it seems like people were able to do it from the comments. And now let's talk about this bit of a conundrum. Because when we think about data science, the practice of it, and we actually have one or two practicing data scientists here, there's a lot to it. The software is an integral part of work in data science, and there's a temptation to build more and more functionality into the software we want to use at the school level. But if we do that, we make the interface harder to use. There's a balance between functionality and interface. Someone's typing and it's making a clattering sound. So
Sorry, that was me.
If you could mute, Rob.
I will mute.
Thank you. This is Rob Gould. Thank you. So what are your thoughts about how to strike the right balance in this in data science education software? And I notice one comment up there is hide the advanced features. That's certainly a common technique.
I think there's at least two modes that a data scientist does and that a student would do. One is an exploratory mode where you may not really want to keep a trail, you just want to explore the space. And then there's a mode where you want to keep a record of what you're doing, as it were. It's kind of the difference between noodling around versus making notes for yourself.
And do you think that those two modes will apply to learners as well? Jenny's nodding her head.
Think of it as the difference between inductive and deductive, maybe. But yeah, there's some students who will always start wanting to keep a record of everything they did. We all know those tidy students where their notes are always neat. And then there's the other one who is good at exploring and doesn't get limited by what they see, but they sometimes need help putting together a coherent record of what were you thinking.
We know that, sorry, go ahead. Was that Dan?
Yeah, I was going to chime in. One of the things that we've been faced with this similar kind of thing on another project in which we're developing a modeling tool called Sage Modeler and trying to reach back to earlier grades. I think perhaps Jenny mentioned that. We have a sort of settings for the software where one could choose, I want this to be in kind of basic mode or more advanced mode. And I think if you were targeting different learners, for example, that might be a way to, have if the interface were somewhat configurable as to what kinds of things were available, that might be a useful way to balance the functionality and ease of use. It's definitely always a tension between, how flexible is your tool and how hard is it to use. More flexible almost always means more difficult because you just have more options.
Mm-hmm. Great. So this discussion that we're having about ease of use, onboarding, we could have that about any school software, and it would, any school tool software, I should qualify that, because when you provide students with a tool, then there's this issue of how much functionality and how do you keep the functionality from cluttering up the interface so that it's difficult for students to get started. Now I'm going to move on to the next slide. And this is particular to data software. And it takes advantage of a feature that we've implemented in CODAP.
Bill, I think you jumped 2 slides ahead.
Oh, thank you so much. Oh, good. Okay. So GIS, geographic capabilities. So in this, I'll ask you to choose either Birgit, the giant tortoise, which is point data plotted on a map, or countries in alcohol, which is regions, all the countries of the world and their alcohol consumption. These are both very different documents, and you won't have time to do both, so you'll have to commit, but you can come back and play with the other one later on. And again, well, there are 2 columns here for comments. The left-hand column is just to think about the relevance of this kind of data and how important it is to have the ability to work with this kind of data in school level curricula. And then what are the important capabilities for GIS in your mind? So again, go off and explore one of those documents and come back here and write your comments. I think I'll choose countries and alcohol. Oh, look at that.
Bill, on that servings, is that, you know, per 100,000? Is it total?
The servings per year.
Per person.
Per person, right.
Right, I was just trying to figure out that unit there.
Yeah. And I think that the total alcohol is liters per, I don't know what it is actually. More documentation, huh? Provenance. Now there's the danger that you'll get sucked into a black hole in either one of those. So as soon as you've got the idea, pull back out and think about your experience.
Interesting.
Yeah, I want to make sure you noticed that you could select a country here. Come on. There, and then have it come up the table. I think that's Brazil. Yes. Oh, and of course you can make graphs. Do you think there's a correlation between beer and wine? No.
Did not see one. I just tried that one before.
Uh-huh.
Yeah.
Yeah, wine seems to be counter, and it doesn't seem to have a connection there, although spirits seemed like maybe there was a.
Spirits versus beer?
Yeah.
Nah.
What about total alcohol and beer?
Yeah, but beer is part of total alcohol,
Yeah,
right?
that's true.
All right, are people writing in the comments yet? Yes, good. Whoever wrote X and Y axis selection may be improved. Maybe you could write a little more about that. I'm not sure what it means. Yeah, citizen science efforts. The Islamic world is low on all of these. What does low on what? Oh, yeah, alcohol. Right, a finding. Yeah, it's quite striking in the map, isn't it? Yeah, it's interesting that the maps have layers. And understanding how to work with those layers is an interesting challenge. And making it easy to work with the layers is a challenge as well. Mm.
Interesting.
Okay. I'll give you a couple more minutes.
These are great comments.
Very interesting. Does everybody see the same anonymous name? You see anonymous gopher?
That's a great question. I've always wondered that. Yes, I see anonymous gopher on the
Okay.
purple cursor.
Oh, I can tell who hasn't written a comment yet because they're still up here. Anonymous skunk, Tom. Come on, Tom. Tom, yeah, I guess you're forgiven. And Joan. Okay, so first to the question of the relevance of GIS data and commensurate capabilities to school level curriculum. Do pre-college students need to learn how to work with GIS data? Up, down?
Well,
you can't see me, is that right? Put your thumbs up or your thumbs down.
It depends on what you mean. Do they need to know how to work with GIS data, or like if you just mean geospatial data, or do you, I don't know, it sounds a bit formal to say it's GIS data as opposed to being able to just work with data that has sort of a geo component to it.
That's what I mean. Relevance of data with geographic component? Geospatial component?
Yeah.
That still sounds pretty...
Well, I imagine kids like trying to process, you know, latitudes and longitudes and having to understand what those things are, but you know, we don't necessarily need them to understand that. They see the dot on the map and like, that's enough. And I do think that, you know, being able to work with that kind of data is useful.
Yeah, it's location data or where is it data if you were talking to really little kids.
I think I'm going to chime in because I think it's really important for them to know that, because understanding where things are in the world can help them then relate other information to that location. So a good example is the Ring of Fire would be a great example, right? So they need to understand what is the Ring of Fire, where it is, what does that mean, and then that can relate back to their understanding of plate tectonics. And so if they don't know where that is, it has no meaning. So they have to understand all those layers in order to put the whole thing together. I mean, that's what, when people say STEM, that's what they're really, that's what they should be referring to, is understanding all those different layers of knowledge so they can get the bigger picture. So I would say absolutely yes.
Anybody want to take the opposite point of view, just for the sake of argument? Well, I'll give it a try. Well, you know, maps are really complicated, and I think we should leave it until college level. No, Maggie, why?
I mean, I think, we work with middle schoolers here, and we've had students involved in analyzing data to monitor the spread of invasive species or the impacts of climate change on their specific region. And I think the geospatial aspect combined with the, you know, concrete connection to local place, I don't think that you can have real place-based research if you're not also going to tie in the geospatial aspect.
Mm-hmm. And Rob, part of your project in LA Unified had them working with geospatial data, right?
Yeah. Yeah, so they were collecting data using their cell phones, smart, whatever their mobile devices were, which automatically records where they're at. And so that data then could be plotted on a map. And, so that leads to some interesting privacy issues, but also does a good job of kind of selling home what privacy issues mean, because at first blush, kids are often quick to wave aside concerns about those things until they see, hey, that's me, that's where I was yesterday, and I didn't want everyone in the class to know, maybe. Now, we do let them decide to hide that information, but sometimes they don't realize what it means. And the other thing I was going to add is, several times we've had kind of interesting and tense discussions when maps have been brought up that show local, depending on the level of detail. So one was centered along a Netflix map of popular movies that were rented. And the popular movies pretty closely follow kind of racial neighborhoods in the area. And what was another one? I mean, so it's been kind of interesting how those really have brought out the need for us to recognize that teachers have to be very well trained in handling the sort of discussion that social science teachers are well trained in.
Uh-huh.
Every 10 years we have redistricting, and it's coming up soon. And without mapping information, you have no idea what is a district.
Uh-huh. So that's an example of the relevance to political science and
social studies
and basic citizenry.
Mm-hmm. Or or questions about food deserts, which people talk about. If you mapped population and prevalence of high quality, low cost supermarkets.
Just a quick note too is I think that maps are becoming so much more familiar to students than they used to be because of the prevalence of Google Maps and how much they are just present in everyday life. And so I don't think it's the kind of complicated task maybe that it was before students had all that exposure.
I had just two more points I guess I find interesting about maps. I mean, one is they are much more familiar, and I think that's a great thing, but more and more they're familiar with points on a map. And I think often to interpret maps, we need to start moving them towards smoothing of some kind. In the same way that we move them from dot plots to histograms, we need to move them from points on a map to heat maps or something, that's another common thing, and get them being able to better read trends and patterns within maps. For the turtle thing, it's not such an issue because the points are so rich. And the issue is kind of pushed under the rug with the alcohol thing because you've decided that the unit of observation is the country, but you didn't have to. I mean, the unit of observation could have been the point of purchase or something like that. So I think that's an important skill. The other important skill, and
just to interject, is this that I'm showing now what you mean by heat map?
Yes, it is. That's beautiful. I didn't know you could do that.
Oh
yeah. Yeah. So I think that transition is really important.
Yes. Okay. Now on to your second point.
The second point is handling the data as data. So I think there's an insight to be had that I know my college students are shocked that they can actually plot latitude and longitude on a normal plot because it's just XY coordinates. And now it's not just XY coordinates in GIS, but to an order of a couple of ordered degrees of approximation, it's good enough. But also learning then how can I collect latitude and longitude data? What form does it have to be entered in, and how does that relate to what I'm viewing on the computer and that sort of thing? I think. Like that.
Yeah, one of the challenges, I think, with maps is, when we have a shaded area, that's fine, or points on a map, that's fine. I think the heat map here adds another level that's a little more challenging for students to parse and understand what it's showing. But that in general, map-oriented data, once you get beyond trying to show one variable, can be quite difficult. So we've seen lots of creative uses of maps, especially in the sort of political arena, where they're trying to show how many people of which, voted which way and which thing, in which, state, and what's the influence, and there's the distorting kinds of maps. And someone said about food deserts in population, like, how do you show those two things together? I mean, we talk about layers as one thing, but oftentimes with layers, you can't really see the two things at the same time. There's some more flexibility. I guess in some ways I'm trying to take up Bill's devil's advocate point of view.
Yeah.
That there's more flexibility within the graphing tools that we have to show multiple variables and their relationships to each other than trying to show that in a map view.
Well, a very common use case in a map view is to have a layer which is area or grid based that represents an attribute of a region, and then points to represent other attributes. So the case of a food desert is typically you have population density as a grid, and you have the location of discrete stores as points.
I'm just saying that there's numerous ways that people have tried to do representations with maps that are, some of them are standard and some of them are very creative, but that inherently it becomes potentially difficult for students to start to read some map-based representations once you get beyond trying to represent the association between more than maybe location and some piece of data.
I can make one recommendation of prior art that might be worth looking at. There's a company called Guide K-12 where it's basically, think of it as selling mapping to school districts for the purpose of making policy decisions, such as which schools do we keep open, or where do we cite that particular program. And they use it because the visual data that can be generated quickly is something that can be used in school board meetings. So instead of having to say, we'll have to get back to you, you can get to much more of a consensus on some of these thorny questions. And so that's an example of mapping data used for a non-specialist audience that is going to make weighty decisions based on what they see.
Great. So I've been kind of playing around in the background here in the screen share just to show you some of the things that we can do with CODAP. So I'm hearing that we're all thinking this is an important kind of data, but there are lots of issues, and among them, Rob mentioned the issue that teachers aren't necessarily prepared to deal with the stuff that comes up when students are working with maps. And I know that's especially true of math teachers, but I suspect it's true of other teachers, maybe less so of social science teachers. Anything else you want to say about this before we go on? All right. Is this working? Yeah?
Yeah.
I hope you haven't left, so it must be moderately interesting. Okay, so this next one is will be less familiar to many of you. And it's about data structure. So in school, we have mostly dealt with small, flat, meaning rows by columns data like spreadsheets show things. And here we're going to play a little bit with changing the structure of the data and seeing how useful that is. So there's only one document to look at this time, and it's called Fast Plants. And the investigation suggestions, if you would start by making some graphs and try to figure out with those graphs what's going on with these plants that are being grown. And in particular, if you can work your way towards determining whether light has an effect on the plants, that would be good. Now, when you've done a little bit of graphing, then switch to the second bullet here, which is to reorganize the table by dragging column headers. And I'll just demonstrate that so that there's no ambiguity about it. So you can see I'm dragging here and I let go, and now we've got a reorganized table. And there's a little screenshot of what you're aiming for over on the right. And once you've done that, then investigate, see what the reorganized table gives you. So those are your instructions. Go forth and investigate. Jenny, are you asking a question? Because you're muted. No, okay. Sibel, is this all working for you, or are you stuck without a
yeah, it's difficult with iPad. Yeah.
Yeah.
Now it's even slower. In the beginning, I could drag things and I could make graphs, but now I don't know if the data set is richer.
No, this data set isn't
No.
too big, but as I said, we haven't optimized or fully vetted for iPad. So you get the flavor anyway.
Yeah, yes. So I appreciate when you share your screen to show things that you can do.
Yeah, I guess I should play around.
Yeah, that would be good.
Even now.
You see the I'm finding this very tricky. What you're looking at doing is what would be called denormalizing or normalizing a table, normalizing a single table into related tables. And yet I could see why to do this. I just have no idea how to actually manipulate it in the software.
So you're having trouble doing the restructuring?
Yeah, well, it talks about reorganize the table by dragging column headers to the left.
So
dragging
can you see my screen here, Doug?
Yep.
Okay, so I've got one of them, and I drag it over to the left, and I let go.
How did you get started? How did you get the first table, that first column? Did you just drag off to the left entirely, and that does it?
Not, well, kind of entirely. So to get the first one, I drag it into this area here.
Ah, okay. Thank you. That was the missing. That was the missing thing.
The key. Now I'm going to, since I'm a CODAP cognoscenti, I'm going to make a new attribute and call it max height. And give it a formula. Let's say max, yes. And insert a value, height. So if I plot max height, and then split by light. Whoa. Now, okay, I'm looking for comments now. If you're confused, you can write for liabilities, confusion. Yeah, I forgot to describe. What we're going to talk about is benefits and liabilities that might come from using structured data. And then, as has become usual here, what capabilities do you think are important? I'm kind of, those of you who haven't experienced this before, are being dropped into the deep end. We found ourselves in the development of the software gradually coming to understand what we had wrought by providing this capability and appreciating it more and more. Oh, you may not have realized that you can actually drag one level further. And now I've got the sun and the shade separated. And I can click on them. And if I want to know about Olivia's plant, I can click on it. So I've discovered how to track your progress. I watch the little markers move away from fast plants and down into the other areas. This is almost like a classroom. Yeah, meaningless structures. That was quite a sigh. Okay. So just to bring everybody to a similar place, I did this reorganization here in this document that I'm sharing. And so I have plants and I have the conditions of the experiment, sun and shade. So there are 3 levels, and we can think of the cases in the lowest level as being the measurements, and the cases in the middle level being the plants. And at the top level, this is a little harder to think about, but we could say these are the 2 experimental conditions. And there are just 2 of those, so that if I make a plot at here I've made a plot at the measurements level. So I get all 200 measurements showing up as points. And here I've made a plot at the plants level, and so I get 10 plants. And what do you think if I make a plot of just the light? I get 2 points. And of course, if I click on one, then it highlights it and all of its quote-unquote children. And the fact that I could define this new attribute with a formula that computed based on the measurements meant that I can get useful measures that I can use to quantify the difference between the sun and the shade. And I can even come here in this and plot the two means. So now we've all got the same visual experience of this. Let's look at what people said. The benefit of providing the ability to organize. So just, I take off on that and think of, again, the world is not flat, and if you're going to model the world, then it's not always going to be easy in a flat structure, and it may be easier in a hierarchical structure. So even this experiment that had measurements and plants and levels, for me, it becomes easier to think about. And the liability of making meaningless structures. And believe me, we have made a lot of meaningless structures. It is both a liability and a benefit because those meaningless structures cause you to think in weird ways, and sometimes you learn something. And it's very complex for 4th through 8th grade. We've got some research with middle school students that Joan and her crew did that shows that they can make sense of that fast plant. In fact, we used the fast plants data, and they can make sense of that display. Can they create things like that? We don't know much about that yet. So there's research that's needed. And being able to restructure the data probably makes it certain questions appear that might not otherwise appear. Like just the fact that you can see how many students there are or plants there are at a glance, whereas in the flat table you couldn't see because they were, 200 down. Changes things. Students might understand the need to group measurements by plant, however, the words and the emotion don't correspond well. Yeah, and as I mentioned, I think on a previous, I think our job as software designers is to make things memorable. So that you're not constantly in the situation of not remembering how to do something that you know it's possible to do. But it's not always possible to make it intuitive so that you discover it on your own. And I think that's certainly the case with the interface that we have here. Students might understand the need to group measurements by plant. Okay, we did that one. Liability, it definitely adds another way for things to go wrong. Students will take means, but will need to ask mean of what? I'm not sure how easy it is for someone reading their work to see what group they've computed the means over. Yep. I think that says it well. Some situations are inherently hierarchical, so more ability to represent range of possibilities, so that's a benefit, presumably.
Bill, regarding the liability you were just looking at, I mean, within the table, it's very easy to see which mean is, you know, how it's grouped, but is the comment, I guess I'm asking whoever made the comment about if they make multiple means in different places, or if they try and move the mean calculation to different levels, are they confused about what they would expect, or?
Anyone want to comment on that? I'm hearing someone talk. What's that?
That might have been me. There's a meeting next door to me, and I just muted.
Oh, okay. There, thank you. Okay. So as far as additional capabilities, being able to visually compare the effects of different treatments side by side, it's important, and we could see certain ways to do that. It would be nice if we could nudge learners to understand which observations are likely dependent on others and which are independent. That is, could we use structure to help clarify what's going on in the experience?
Yeah, let me add, I mean, so that was mine, and that the other one that was mine was the thing about how it adds another way for things to go wrong. And I guess one concern I would have offhand is this doesn't really, it places all sort of structuring on equal footing, you know, as I think it should. You know, you move things over and it restructures them, but it doesn't, but some structures are more appropriate than others, and some structures will lead to a stronger analysis than others. So somehow I would hope for that wouldn't get lost. You know, the notion that measurements within plants are probably dependent upon each other, but measurements across plants are independent. So I'd like to have some curriculum or something that supports that understanding.
And it brings up the need for that curriculum, which takes time away from other things going on in the classroom. Yeah. Well, I was going to illustrate Rob's confusing structure, but actually I won't. It takes too much time. So I'm excited about the idea that students can work with data that has other than the flat structure. And I don't think that hierarchical is necessarily the only or the best way to do it. It just happened to be the one that we stumbled on. Certainly other ways of relating different data sets is possible. And if you take a computer science course in data structures, there's all kinds of data structures that may or may not be useful in data science.
Can I ask a question of the group, Bill?
Please do.
I was thinking about what data reorganization capabilities and what Rob was just talking about. It's not exactly the same thing, but one of the things that we had tossed around, or at least I'd thrown out there at one point, was when you go to, for example, when you go to move, if you go to make a hierarchy for plant ID, there's only one name per ID. Like, should you get some kind of hint that these things go together? I'm just trying to think about ways to help students if they're given a flat table. How do they start to make useful structures out of it?
So looking at this flat table, Dan, can you say your question again?
So if I'm thinking, okay, I want to organize by plant, but there are some other things that go along with that that are the same. So, you know, like Matt always goes with K, and Sun always goes with K. Maybe when I drag plant, Matt and light should, you know, observer and light should come over with me or something.
So instead of having to figure out that observer and light can come over here, have it done automatically.
again, there's stuff you do for kids, or there's hints you give them, or I don't know. Does some features like that even help you even explore what kinds of ways the data are related to each other? Anyway, that was just around this. What kinds of capabilities do we think are useful? I don't know if that's useful or counterproductive.
Yeah, you and I probably have strategies for figuring out which things can come over. Mine is, well, let's see, I've got 10 plant IDs now. I wonder if I bring Day over, how many plant IDs I'll have. Oh, 200, that was a mistake. So I'll put it back, I'll undo that. And so I'm looking to keep this number up here constant. Okay. Now don't close that tab in your browser. Hope you haven't already done it, because the next capability is journaling. So this has already come up when Doug was talking about 2 modes of doing data science, the messing around mode and the keeping track of what you're doing so that you can show it to other people mode, I guess.
Yeah.
Okay. So
there's a difference between being a pathfinder, exploring the wilderness, and then describing your journey.
Yeah. So the software could help with that. CODAP doesn't help with that. So for the exercise, I've asked that you go back to the FAST plants that you were just working with and make a text box and just spend a few minutes trying to document what you did yourself. And that will get us all grounded in what it would mean to have a journal, a human readable journal of what you did. And I don't think that'll take long. I'm not expecting you to do a thorough job. And then go back and think about these 2 questions. Getting novices to care about documentation is tough. Why is it important, and what might motivate learners to make use of it? And then what are some arguments against including automated journaling in the software? Oh, this time I can't tell what you're looking at. Okay.
Sorry about that. We're typing over each other.
There's a whole etiquette of group editing that we have to learn. Oh, that's a good question. What do I mean by automated? The moves that you make, the things you do with the software appear in a log of some sort. And you can read restructured such and such data set by moving plant ID to the next higher level. That's probably not helpful, but you know, the software would attempt to write things in a timeline for you that you could go back and study, and maybe fancy things like if you click on one of the items in it, it takes you to that state. And there's all kinds of possibilities that have been explored in lots of different software environments. Okay. So why is this important? Is it important? That's your cue, Rob.
Keep forgetting I'm muted. That's my cue?
Yeah, you're the advocate of journals.
Oh. Yeah, well, so one thing is, I think it falls into this category of things that are listed when people list computational thinking. One test, I think, of solid documentation is you can turn your work over to someone else and they can repeat the analysis that you did. You know, maybe not stroke by stroke, but come up with the same graphs, come up with the same summaries and statistics that you came up with. And that would include dropping, changing, altering structures or data points. The other thing is, like, I just noticed myself when I'm journaling alongside. So I pointed out that I felt like I was doing, I said two, but actually three things at the same time. I was trying to describe what I had done to the computer. And I was trying to say what I had learned from that and what I wanted to learn next. And I definitely found that by saying what I've learned, it pushes you towards thinking about what you want to learn next. And I noticed some things that I had forgotten about that I should have done the first time. So, you know, there's kind of a, hate to be trendy, but a mindfulness to this act that helps keep you on task, I think.
Mm-hmm.
There's a body of research. The person is Brian Hand at University of Iowa, and he had a IES grant that recently ended, and he used what he called a science writing heuristic. And although it is on paper, I think it's the same idea, and I wrote it in the box, that students have to make meaning from what they are doing, and if they don't write it down, that is lost. And actually creating graphs and collecting data and all that has been shown to not increase learning unless they do that part. They have to actually write it down. And he actually showed increases in math performance. And he didn't change anything about the curriculum or about what they were doing. The only thing he did was had them use this writing heuristic, and then it improved their math performance. So I think that speaks to the value of that.
So I worked long ago on the Geometer Sketchpad, which had the ability to write your own documentation as a user. And it would also, it was easy to get it to record what you were doing and to actually replay what you were doing. And in classrooms, we saw very little use of either of those capabilities. Similarly with Fathom, though authors used the ability to put text into a Fathom document or a CODAP document for that matter, we saw very little use of that in classrooms. So granted that there would be benefits, how do you get it to happen? Because even teachers, I believe that the main reason we weren't seeing it was not just that the students weren't motivated to do it, but that the teachers weren't motivated to require it.
You have to make it part of the lesson structure. You have to give them professional development on how to structure the lesson, and you have to make it part of the lesson structure. And if you don't, then they won't see and you have to show them the value of it. You have to show them that when your students do this, they actually learn more. And you have to show that value to principals, to everybody that makes curriculum decisions and how lessons are structured. You have to show them the value of that with data and show them that if you don't do this, just go back to using the textbook. It doesn't even matter, right? So that's what we try to do, because we struggle with that too. A lot of our teachers will do the hands-on lessons, they'll have the data, and then they'll go, oh, bell rang, time to go, and so we have to teach them how to structure that lesson, and there's a certain amount of hand-holding that goes on.
Yeah, I've seen classes where the end of the period is approaching and students are really engaged with the activity, with the data, and the teacher is faced with this decision: should I get them to stop and turn to writing? And they say to me afterwards, well, no, they were really learning there. I didn't want to interrupt that. And I guess you're saying, Jenny, that maybe they aren't actually learning. They're just having fun.
But I think, adding a layer of, sense making at the end, after they have gone through the experience, I think, that's part of, what Brian and his group is trying to do is kind of give students, reflections on, what they have learned and kind of synthesizing, all the components that they have been exposed to in a written format. So, like you said, Jenny, it's having this lesson structure and providing, professional development for teachers is very important, because they have to be convinced, and not politically convinced, by epistemologically they need to be in the same page as you are when you're trying to engage them in the practices that you want to promote through this tool.
So Maggie, were you about to say something?
I was just going to say also, the things that get left off are the things that are left till the end. And I think providing models or incorporating a structure that incorporates reflection throughout and not just at the end is a way to just have more success in implementation.
So what about whether there should be help from the software, this automated journal or log?
In my comment, I mentioned in the left column that I think of it as the difference between play-by-play and color commentary. And I think it's very reasonable to have the software automatically do play-by-play, and it's very educational for the students to do their own color commentary. Why was I doing this? Why was I thinking this? And if you had to split it over 2 days, where the first thing you do on day 2 is to, you're home, you're like, okay, when you go home, look over what you did and be prepared to, to discuss with each other why.
Mhm.
That's just the thought. That there are two different kinds of things being logged: the what and the why.
Yeah, go ahead.
In terms of the automatic logging of things that are getting done, if it is at a very low level of, you know, changed access to blah, or, you know, dragged such and such column to the left, I feel like there's a lot of messing around that students are doing while they're exploring, and that will get a generation of a lot of stuff they don't care about. And, you know, it's much easier for me to actually look at the end product to figure out how they've thought about it, plus, you know, the color commentary, than looking at the automated log. I guess that's where, you know, the question about what do we mean by automated, and are there higher level things. You know, I was looking at my fast plants work, and first I graphed, you know, light versus number of leaves. And then I realized I didn't really want number of leaves, I wanted max number of leaves. So then I made a new hierarchical level, and I calculated the max number of leaves, and I did light versus that. And what I really wanted was to just, you know, well, one could have stayed with the first one, although it wasn't really what you wanted, and it potentially distorted, you know, the numbers you might, the aggregate values you might calculate. So the thinking behind why to make the change feels like it's important to articulate, but I might even then suddenly go, oh, I wonder if any other things are related to light and shade. And then I start moving all kinds of stuff around and making graphs and throwing them away. And if I had this automated thing, I just have all this interim stuff. And Doug, you've mentioned a couple times about there being this mode. And I don't necessarily know that there's the all messing around mode and then there's the all sense making mode. I feel like they go back and forth between those things.
That is correct. I see one of the benefits of keeping of the automated low-level log is it really does capture the productive struggle or the non-productive struggle. And it's when you go back and if the log is not so much for reading as for reviewing what you did, there's a big difference. You know, if the log is simply a textual description of everything you did, it may be hard to piece it together because it doesn't look like what you did. It's text. If it is a second representation, so that you could do things like highlight, you know, if you could review what you did and see yourself doing it, if the log is that level of detail, and then you can stop and maybe mark something and saying, this was the critical point for me. That gets them reflecting as to the why they did something and can be the basis of discussion with other students and with the teacher.
One of the, I was discussing with a project that we didn't end up putting in a proposal yet, but you know, this idea of storytelling with the data set and being able to kind of capture, here's the status of these key components, and let me tell you a little story at the moment. So like a quick way of saying, capture this graph or the table or the whatever, and then some description, being able to add that to like a scrolling pane of something is something that we were talking about doing, but we didn't really flesh the idea out that much, other than you know, one can, like you said, there's certain, like I'm fooling around a lot, no, this is important. And one of the things, I guess one of the liabilities, I'll bring up another liability from the restructuring piece, is that if I move something that I've graphed from a lower level to a higher level, in theory, I think it should also update the graph because those are all live and connected. So I might lose my original representation or that went along with that.
Yeah.
And if one could sort of say, capture this moment in my document and let me write something about it, But
Yeah, I think that would be the dream of the automated journal, that each of these things that you did, you could click on it and it would take you back to that state. And you could say, well, now I'm going to go in a different direction from where I went, and somehow it would keep track of that too, and a tree or whatever. And these things get very elaborate, and there has been research at least at the practitioner level of what people do with these things. But it's remains a question for me how much use it would actually get in classrooms. And if it weren't going to get used, then it would be a big effort to no purpose. But that takes research. Okay, we have about a little less than 15 minutes of the webinar left. And I'd like to say I saved the best for last, but I don't think that's actually true. This is a list of what I called software design guidelines for data science software. It's not the full list that is in that document. I took out a number of them. And what I'd like you to do is read down this list. Some of you should start at the bottom, and put an asterisk in front of 2 of them that you think you're most interested in spending the remaining time discussing. So if you think creating simulations would be an interesting thing to talk about together, then you would put an asterisk in front of that. Clear? Somebody has some speech going on in the background.
Sorry, that's me again with the muting.
Thank you. Let's see, all I have to do is count the number of asterisks. Okay, I'm seeing 2 of them that have got more asterisks than any others. And the first of those is do big data. So, what do we mean by big data? Different for each context, right? It depends. But we want students, I guess the idea here is we want students to engage with quite large data sets so they know what's possible. On the other hand, oh, I'm getting an echo.
No, that was me starting.
On the other hand, we want, so CODAP has this nice attribute that it's browser-based and it's entirely within the browser. And as soon as you give it very large data sets, it bogs down to be very slow, unwieldy, and not fun at all. So medium-sized data sets, 5,000 cases or whatever, are fine, but 100,000, and once we had one with 3 million that eventually did display, but not useful in the classroom at all because they become so slow. So I think dealing with big data is going to come about through what in CODAP's terms we call plugins that sit inside CODAP, and I should show you one of those.
While you're getting there, Bill?
Yes, please.
I want to mention why I started this one. And it wasn't so much that I felt like students needed giant data sets to be able to engage in data science, or for teachers to engage in data science education. But that there are, we've talked about them using, real data or data they can find online. And frequently those data sets are large enough that they can bog down CODAP. And what I would like is, the ideal would be for CODAP to be able to handle some of those typical public data sets that are available without having to, do something special with them.
Yeah.
It's not so much that I felt like kids really have to handle 1 million data points or else they're not doing data science. It's just that those are the data sets, not millions necessarily, but tens of thousands certainly that they would encounter on a regular basis if doing a search.
Yeah, good. I wanted to show you what I meant by a plugin. This live data set is not part of CODAP. It's just a little application that's dropped into CODAP as what we call a plugin. And what it does, this particular one, is in real time, it goes out and gets the last week of earthquakes and brings them in. So it's a way of getting access to a very large amount of data, but just a relevant slice, perhaps, of the most recent data sets, most recent earthquakes. And I don't know why there are these 3 groups. There may be a bug here. Let's see if I do fetch. And it updated, but it didn't get rid of the points. Anyway, you get the idea. We've talked about ways of CODAP or any piece of software doing sampling for you in very easy ways so that when your data set is too large to look at all at once with the particular software you've got, that you can very easily get a random sample of it and take a look at that as an example of a way to give students the experience of large data sets, but in a way that lets them do something with ease. And of course, this is the way of data scientists actually work, is not to deal with the terabytes of data all the time, but deal with samples of it. And then when they're ready to, if there's something they want to find out for the entire data set, then they can do calculations that take a lot of time. Andy Rubin, whom some of you know, has got a nice piece on just the right size for data. That is, that it depends on the classroom situation how big the data should be. And so I guess in the days before we had easy access to computers in classrooms, data sets were limited by what you could write down on the textbook page and what you could plot by hand. And we're not in that situation anymore. And so we can deal with larger data sets. But in the classroom, we still can't routinely, with educational software anyway, deal with millions of cases or rows. So we have to come up with ways to give students access to that data. I think I've started repeating myself. Anybody want to say more about this? Okay, that leaves us 3 minutes to talk about creating models.
Which was a popular one.
Yes, it was a 4-star. And one way to do this would be for me to stop sharing my screen and for Dan to take 2 minutes to show us modeling inside CODAP. Can you do that, Dan? Okay. One of the projects that Dan and I work on is called Building Models, and it's based in CODAP, but it has its own plugin called Sage Modeler. Go, Dan.
Okay. I was wondering if this was the kind of model that people were thinking of, though, or if
it probably isn't, right?
I think people were thinking about statistical models or things that generate.
Yeah, you're right.
Like,
But this is so cool, you should show it in the remaining minute.
Well, this was designed, this tool was designed to allow students to take their mental models of how they think something works, some kind of phenomena, and create a representation of it, but then also to generate data from it and potentially compare their data to external data sets.
So without much commentary, show us that.
So, for example, if I wanted to, if we were looking at ocean acidification, for example, one could say, well, I think that you know, there's something about the CO2 in the air, and so I might want to find some image for air, and there's one that I usually use, which, or even wind. I think this is what I usually type in when I'm looking for my air thing. But let's just do something like this. So we've got our CO2 in the air, and I think that that's going to have some effect on CO2 in the ocean. And so I might look for something that represents ocean. And
now you don't get to make any more, Dan, because we're out of time.
And so I can connect these two things together, and then I can define a relationship. An increase in CO2 in the air causes CO2 in the ocean to also increase, decrease, or vary based on some way that I can define. And so if I say increase, then I have some choices about the same, a lot, a little, more and more. So those kinds of things. And there's a representation here. Now if I go into simulate mode, I can record a data stream of as I'm changing the CO2 in the air, how does that affect the CO2 in the ocean? You can see my data is being generated into CODAP automatically. And I can make a graph. And I could look at those things and how they co-vary with each other. Or I could, you know, look at, if I want to look at as I change the CO2 in the air, how does it affect the CO2 in the ocean? And we can create complex models of this using this tool. So this is something that's a model that I can create. It generates data into CODAP, and then one can imagine how you might want to structure the data. Right now it's structured by experiment, because if I want to then try some other thing, a different kind of...
Okay, now we have to stop. Thank you. That was wonderful.
Yes.
That, in fact, was the kind of modeling I was thinking about.
Oh, okay.
Okay.
Good.
I was thinking about you know, part of the reason we go the other way and look at the data and get statistics is we try to infer and get insight into what the underlying process might be. But there's nothing wrong with postulating processes and seeing if they're radically similar or different from data.
Yeah, good.
Yeah, so one of the things I didn't show is that we have data from, NOAA about CO2 in the air and the ocean and the pH. And I can see, does my model generate similar data to real world data? And that stuff can be pulled in easily into CODAP.
Okay, so I hope this worked for you. I enjoyed myself. And this is part of a series. So Talia, what's the next one?
Yeah, so the next webinar is going to be on February 16th with Tim Erickson of EEPS Media. Tim's going to be speaking about binary trees in relation to the work he's doing for Project Data Science Games. I'll send out details shortly, and I'll also send a tweet about it. Is there anything else you'd like to say?
No, just thank you for coming. Thank you for being so much participatory in this webinar. It was a good experience.
Good fun.
Yeah, I just want to say this is a wonderful, wonderful group. You guys were really, really great at participating. You kept me very busy in the back channel, and I appreciate that.
Oh, I wasn't even aware of that. Wow.
Yeah.
Okay, bye.
Bye, everybody.
Bye-bye.